electronically actuated nozzles versus air atomizing nozzles. Now, air atomizing nozzles are a great way of getting fine sprays to go where you need them. They're commonly used in a variety of coating applications and precision spray applications. With these types of nozzle, the air is used to atomize the spray and to drive it onto the target area. Now, this can be combined with air actuation, so you're using the air to shut the nozzles on and off, and you can get some fairly impressive response times there, up to about 3 on-off cycles per second. They're very, very good for spray control. Now, electronic nozzles like our EHP system, controlled by our FlexFlow control system, are a good alternative to air atomizing nozzles on, say, a coating application. Now, these nozzles have an integrated solenoid valve within the nozzle body itself, and they can very rapidly shut that orifice on and off at either 50 or 150 times per second, depending on the model. So they don't use any air at all. Atomization of the fluid is achieved purely by fluid pressure itself through the nozzle. So how do they compare? The EHPI, the electric nozzles, will have the following advantages over air atomizing nozzles. First of all, they reduce mist. So if you're spraying an oil or something like that with air atomizers, then sometimes it can be a bit messy. The air helps to carry finely atomized spray to its target, but you can get an oil mist coming off of that. So it may not all get to where you want it to go. It may mist up in oil mist in the factory, and that can get very messy. It can also get very, very wasteful. Because air isn't used in electronic nozzles, you're just using fluid pressure, you don't get so much of that misting, you don't get so much of that spray carry, and so you can reduce that misting effect quite dramatically by switching to electronic nozzles. Second advantage is noise. The air is noisy, the electronic nozzles are a lot quieter. That can be an issue in some factories. Thirdly, we've got a lower overall running cost on the electronic nozzles. There's a bigger capex on this type of system, but they don't use any air, they're just using an electric signal to shut the nozzle on and off, and so the running costs are actually slightly lower. It's not hugely significant because the air atomizing nozzles that use an awful lot of air, but nevertheless it's still there, and so the running costs are lower. Finally, the biggest advantage perhaps of the electronic nozzles over air atomizing nozzles is they're actually a lot easier to set up and to adjust. So with air atomizers you have two inputs. You've got an air input and a fluid input, so the variation between air and fluid pressure can be quite a dramatic effect on the spray pattern type and the atomization level and flow rates. That interplay can be quite delicate depending on the type of nozzle. So getting them set up and spraying exactly how you want them to do involves controlling two variables, the air and the fluid pressure. Setting them up can be quite a lot harder. With electronic nozzles, you've got an electronic control system that can control the on-off cycles very, very easily. And the overall spray type that comes out of the nozzle is dictated primarily by the fluid pressure. We've only got one variable to control. So what about air atomizers? When do they come into their own? First situation where you want to consider air atomizers over electronic nozzles is if you want to deliver very, very low flow rates and keep them on target. The air can help drive very, very fine sprays at very, very low flow rates to where they need to go. So electronic actuating nozzles, because they're just relying on that fluid pressure to atomize the spray and form the spray, there's some lower limitations on the flow rates that you can get out of them. So if you've got very, very fine coating applications, you may need air in there to produce a proper spray pattern. If there are practical problems in wiring electrical components close to the spray head, this can be a reason to use air atomizers. So with the electronic nozzles, you have a solenoid valve built into the nozzle body itself, so you need to wire that in to receive its signal very, very close to the actual spray head, just right in front of it. Now, there may be a whole variety of reasons why that's just not practical in the factory. So with air atomizers, you're controlling them via an air supply. You need to get an air supply into the nozzle body, and that air supply can be controlled by a solenoid valve from some distance away, not too far, but some distance away from the actual spray head. The only electrical components can be quite a lot further away from the spray head and the spray zone. That may be useful in many, many situations. Now, if you need very, very finely atomized fluids, air atomizers can help achieve smaller drop sizes than simple hydraulic nozzles. So the electronic nozzles for all of its fancy control system in there. It is at the end of the day just a basic hydraulic nozzle. You can do some things on getting flow rates down over basic hydraulic nozzles with a electronic nozzle by pulse width modulation, which we'll cover in another video. But in terms of the actual atomization of the fluid, it's still just a basic hydraulic nozzle and relies on that fluid pressure to atomize it. And there's some limitations there. Air atomizers can achieve smaller drop sizes, particularly if you're restricted on your fluid pressure. So if you need that small drop size for whatever the application is, then air atomizers may be a very good choice. Next, if we look at spraying viscous fluids, air atomizers can be a very good choice over electronic nozzles as well. The EHP nozzles, electronic nozzles we sell, can correctly set up, can handle fluids up to about 25 centipoise, so 20 times the viscosity of water. So they can handle some fluids. Depending on the fluid, we can get that up a little bit, so it's not quite as simple as just giving a specific number that they can handle. But it's sort of around about that area where they can start to struggle a bit. The right kind of air atomizer can handle fluids of perhaps up to 3,000 centipoise. Again, it's a complicated topic, so no guarantee that every 3,000 centipoise fluid is going to be able to be handled by an air atomizer. It depends on a whole load of other things. The point is the range of viscosity an air atomizer can handle is a lot higher than the electronic nozzles, because at the end of the day, the electronic nozzles are just simple hydraulic nozzles. They're very fancily controlled, and so it is restricted on what it can spray. So if you're looking to spray very viscous fluids, air atomizers can be a very, very good choice there. And then the final advantage of air atomizers over electronic nozzles is they're a lot cheaper in terms of capex. Noted before, they've got slightly higher running costs because you've got air in there, but the overall capex you'll spend on the air atomizing nozzle system is likely to be quite a lot lower.